Great, thank you. Okay, now today we have different subject than what we discussed before. Today we will talk about fire safety, which is an important subject, not only for data centers, actually, it is important in any workplace or workspace. It is even important in residential areas, in your home, wherever you go. Fire safety is something you need to consider. So let's have a short discussion before we delve into the subject. So fire safety. Yeah. Do you think we need fire safety for data center only? Is it something related to data center only? Or we need it even in residential area? We need it in any business area, in retail, in all locations we need it? Yeah, it is not something about data center only. It is something that that is relevant to any actually workspace or even residential areas or wherever we have any properties or humans or people. Fire safety is paramount, and it is one of the main safeties or main considerations to take into account. Now, what is unique about data center? How data center is different than the other locations? Let's talk about the risk of fire. Do we have more risk of fire in data center than maybe residential area? Do we have any additional risk of fire in data center? Yeah, why is that? What are the components that make data center somehow more vulnerable or maybe more subject to fire than other locations? High voltage. Thank you, Daniel. Good point. So let's say the power system. We have high voltage. We have 11K that goes up maybe to 3.8K, then 110, which is maybe a lot of transformers, a lot of switch gears, a lot of equipment, which make it subject to fire. But why is that? Why power is a cause of fire? Because maybe power has resistance. It generates what we call it as a flash arc or maybe heat, and this may cause fire. What else? Extra risk, terms of power and heat. Thank you, Patrick. Electricity actually is a main concern because we have a lot of electrical systems. It is not only power. We have a UPS system, we have batteries, and guess what? Batteries are one of the main reasons for fire because if they are not well maintained, they may explode and they can ignite fire. Voltage, sources of heat. Okay, let's talk about heat. What sources of heat do we have in data center more than residential area? Servers, they generate a lot of heats. In general, any computational equipment, any network equipment, they may generate heat, and mainly if they malfunction, if they don't function as expected, there's a good chance that they generate extra heat, and if there is no proper cooling or maybe proper monitoring, there is a good chance that they may generate enough heat to ignite fire. What else? Do we have any gasoline fuels in data center? Do you think we have any combustion material or maybe some liquids that can explode in data center? Do we have any fuel? Exactly. Thank you, Chris. We have fuel for generators. Remember, we have generators in data center, and this means we need to have some diesel or maybe gasoline or fuel in general, and this can be a source of fire or maybe explosions. So there are many sources of fire in data center, more than residential area, and maybe more than many business areas. And that's why in this lecture, we will talk about fire, and we customize the course to focus on data center sources of heat, data center risk of fire, in addition to general guidelines about fire and fire systems, fire suppression, and fire detection. Now, the cooling system, if everything works as it should be, good question, Marcus. If everything function as it should be, we should have no fire at all. If the cooling system work as it should be, if power system work as it should be, if the servers work as everything and the cooling is all good, we should have no fire. But there's always a risk of malfunction. Maybe cooling system is not working properly. Maybe something is blocking the air in that area. Maybe the CPU is malfunctioning. Maybe the fan on the CPU is not working and the CPU reached to the point where it actually melt. So there are a lot of sources of heat, a lot of sources of fire, and we will talk about them in more details. Now, when it comes to the assets in data center compared to residential area, in residential areas, typically we want to protect our humans, for sure. People are the most important assets. In residential areas, we want to protect the furniture, the houses, the walls. In data center, what is the main asset we are trying to protect? What is the main asset in data center? Yeah, data. Agree with you. Yeah, this is the right answer, data. But in addition to that, what's wrong with my pen? Data, which means servers. So somehow we want to protect the servers. We want to make sure they don't maybe burn. We don't lose the data. So speaking of servers, do you think water is the best way to suppress fire or extinguish fire in data center? Do you think water is a good way to just throw a lot of water on the server and that's it? No, because servers are sensitive. Anything that conduct electricity, anything that can conduct or connect or transfer electricity may actually damage these electronic equipment. So we need to have a way to suppress the fire without affecting servers. And on the other side, we care about the human people who work there. So whatever we use, we should be safe and friendly to the servers, the electronic devices, and also to human at the same time, because we cannot kill the oxygen. I agree with you, Greg, but what about people who are there? It is not nice thing to them. I'm sure they will not like it when you kill the oxygen. In old days, I remember when I worked in data centers in 90s and 2000, we typically see this sign that says, this room is protected by halon, fire extinguisher system, leave immediately upon warning of discharge. So this was a common way to do fire suppression using some halon, which was, I would say, killing substance for humans. But this is not accepted anymore. People are looking for different ways to suppress the fire, to extinguish the fire, to put off the fire without affecting humans. And this is what we will discuss today. We don't want, we don't want this way of doing things. We want more safe. We want much safer way to do things. We don't want to endanger humans in the space. We want to make sure that whatever we use should be safe for everyone. Wouldn't the fire in the server be considered? Now, it is. I would say it is caused by the heat, maybe in the server room, not directly from electricity. Now, electricity is the source of heat because actually the CPU heating is because of the resistance. If you want to take it literally and scientific way, electricity is the source of heat because the heat in the servers is actually because of the resistance in transistors, in diodes that cause heat for this conductive material, and this heat is the source of fire at the end. But it is not direct from electricity, it is from the heat that is caused by electricity. So yeah, we can say it is electricity or heat. So this is the main subject of today. We want to, first of all, we want to protect the people inside data center. We want to protect the equipment inside data center. We want to detect the fire as fast as possible. We want to alarm everyone to leave, to make sure they are in a safe place. We want to also make sure that the material we use is friendly to the people, the servers, and what there's a third component. Any solution we suggest should be safe to people, servers. What is the third factor that we should consider also? Environment. Thank you, Greg. We should make sure the solution is environment friendly. So these are the three factors: people, servers, or electronics, let's say, in general. Electronics and property, I mean to the physical properties, whether electronics or buildings, and also to be environment friendly. Yeah, thank you, Greg and Gabriel, and Bertrand also. Thank you. So with that said, let's move to our lesson for today. So today, we will talk about fire safety, how to detect the fire first of all, and how to prevent the fire. We will talk about the infrastructure needed for fire system and the hardware and different components. And we will talk about business standards and practices. Do you think, as data center technician, do you think you are the one who will install the fire system? Do you think you are the one who will install fire system? Not really, in most cases, because installing fire system needs a specialized company with qualified team, certified team. So not anyone can just install fire system. So you are not the one who will install the fire system. You will be the one to install servers, maybe storage, network, maybe racks, maybe cabinets. You may lay cables in some cases, the UTP and fiber cable, but typically you will never install the fire system. Now, are you the one who will maintain in case of issue? Are you the one who will maintain and fix the issue in fire system? Not really, agree. But you are the one who will monitor maybe. So typically you will not install, typically you will not maintain it. You are the one to monitor it maybe. You are the one to report the issue to the experts or the contractors. So you need to know, you need to understand the system to be able to monitor the system, to be able to report any issue in the system. You need to understand how the system function, what are the components, what are the back end and front end systems that are related to this. PMs will be performed, yeah, I agree. Even preventive maintenance will be performed by vendors, but you are the one maybe to follow the schedule to make sure things that are done in a proper way on timely manner, and you are the one maybe to verify the results. Okay, we are all in full agreement. Good. Okay. Now let's talk about some incidents that happened in the past for data centers, and we will discuss one incident, one of the major incidents that took place on March 10, 2021, which is maybe 4 years ago, in France, in an area called Strasbourg. I think they pronounce it maybe Strasbourg. Anyway, in France, it resulted in significant outage. Let me show you a video of the incident, and then we will discuss it. This is a video of the incident. Oh, wait, let me share with voice. 1 minute. Let me share with voice. I always forget to share the sound. And let me make sure I'm sharing the right screen. Let's take a look. Let's watch the video together, and then we will discuss it. The writing is in French, but I think you don't need to understand. You can, yeah, just see the video, and they have another video even. So you see what was inside the building. What material was used to build to build the building? I don't know what is OVH in French. I don't know. I don't speak French, although I am Canadian, but I am in English Canada. So they use containers. So somehow they wanted the data center. Sorry, they wanted the data center to look fancy. They wanted the data center to look fancy, and guess what? Not only containers. They used plywood. They used some sort of wood to make the decoration from the inside. You read the article, and you will see what mistakes they did that caused this fire to take place and also takes to spread quickly. So they brought containers. They added some wood decoration to these containers, and they use them as data centers. So there are 4 buildings, and you'll see in the article how many of them were totally destroyed. So the containers are steel for sure, but I mean the decoration they use inside the containers was actually plywood and some sort of wood, I believe. And this was the main reason for the fire to spread quickly, and it was out of control. So they focused more on I would say, the decoration. They focused more on maybe the looking of data center more than the practicality of data center, and this was an issue. How many they lost? I want you to read the article. I will give you some time to read the article, and then we will answer some questions together. So after you read the article, I want you to provide me answer for these things. But let's go over the video, and then we will have some time to read the article. This is enough for the video. Now I will give you some time to read the article. Then we will discuss together what is the reason, what is the cause for this issue, how would you, I would say, avoid the same mistake in the future. What maybe could they have done to avoid this maybe. So let's have maybe 2 minutes. Please read this article, and then let's discuss what was the reason for this fire. I will add the reason because I want also to discuss the reason. Could you please, everyone, could you please read this article, which is in the first page of this lesson, and let's discuss it together. I'll give it another maybe 1 minute, just read, or 2 minutes. Let me have the timer. So I set the timer to 1 minute 30 seconds, and let's see. Just please read it. Please even Google, read about this incident, and let's discuss this incident together. Another 1 minute. Another 15 seconds. Okay, let's discuss it together. You can type your answers in the chat, and if you want to unmute and talk about it, okay. So how did the fire get? Let's start by something. What was the reason for the fire? What was the source of the fire? The reason? Yeah, the UPS. The UPS is a source of heat. If it is not maybe maintained, maybe they did not maintain the UPS. Maybe they did not do any proper maybe monitoring. You know that there is a way to monitor the heat inside electrical component. There is something that looks like a gun. You just point to the device. It will give you the RF scan, or it will give you the heat scan for this. We'll discuss it maybe later today. So maybe as a data center technician, you could have avoided this issue if you have proper monitoring for the heat dissipation or the heat generated from different electrical and I would say maybe electronic components, and make sure they all look the same without any additional heat. So there was a way for them to avoid this if they had monitored the UPS and the heat generation. How did it? Yeah, the heat or maybe the batteries. Yeah, some there are different ways. And the other, how did it go out of control? Why it went out of control? Yeah, the wood. They have wood in the furniture. They have plywood. They have a lot of sources of heat. And then, were they able to detect it on time? Were they able to detect the fire on time? No fire system. Yeah, I wonder. This is really bad. They have no fire system. They have a lot of combustible material. And then, how long did it take for the fire department to respond? And do you think the fire department was effective in responding and in controlling the fire? Yeah, the good thing, they managed to evacuate everyone, but there was a railway behind the building. They couldn't access the entrance behind the building. So the location of the building was wrong. Not only the material, not only the construction, not only the fire system, the location of data center in that part of the city was wrong. They don't have enough access to the building. They couldn't access some areas of the building that the fire trucks were not able to go beyond or certain point. So it was all bad. And this was a lesson for everyone to avoid these things. So the fire suppression or the fire safety starts from selecting a proper location for the building. There was no fire, what they call it, there was no sources of water or any safety measures around them. So the location was bad, the construction was wrong, the material were wrong, the fire system was not functioning as it should be. They don't have maintenance for the UPS. They don't have monitoring for the UPS. They don't have proper fire detection. So there were a lot of mistakes. And guess what? I remember in the news that some of the companies who hosted their data in that center, they couldn't retrieve it. There was no backup. They didn't have backup for many of the systems there. So many of customers who have their data in that center, actually, they lost this data for good, unless if the customer has its own data, its own backup. Otherwise, the center didn't have any backup. So this is in a brief what is that incident. So now let's talk about fire. One more question, just to give you some information, additional information about it. So this is it was in March in France, no casualty, which is good. They have 4 buildings. One of them was totally destroyed. The other one was partially destroyed. 3.5 million websites were affected, 250K domains. And the cost was estimated after the math, after maybe it was 122 million, as per some sources. The cost of that incident was maybe the direct cost to the company, to the operator, was 122 million. Looks like they didn't have redundancy for some of the domains and locations. So somehow it was a bad design. They didn't implement it or design it in a proper way. and this adds to the cost. So let's talk about fire in general. Yeah, 0.12 billion and maybe more. You don't know. Sometimes they do initial estimation and then after years, it keeps adding because they lost their reputation. No one maybe will do business with them in the future. So maybe it was much more than 122 million. So now let's talk about fire. Maybe you know about fire triangle. For fire to happen, we need to have three components. First of all, we need to have heat. We need to have oxygen, and there should be some fuel or maybe combustible material. So if we have these three components, some chemical reaction will take place between them, and fire will happen. So on the other side, actually, I don't know a lot about the company VESDA. Yeah, I know about the incident. I collected information only to discuss the incident, but I don't know about the company itself. Does it run its own business, or maybe this was part of Google or Azure? I don't think they were part of any large CSP, large cloud service provider. I think they are independent. They have their own equipment. So let's go back. So these are the three components of fire: oxygen, heat, fuel. If we take it the other way around, if we have fire already, and we want to suppress this fire, we want to extinguish this fire or suppress the fire, maybe we should take out one of these components to suppress the fire in the fastest way. For example, how can we take the heat? If we have fire already, fire in the building, and we want to use this concept to suppress the fire, to extinguish the fire, to put off the fire. Let's start by heat. How can we take the heat out of the fire to suppress the fire quickly? We want to take the heat out of it. Now the issue with ventilation is it brings oxygen. If we put a lot of air or ventilation, then we will bring a lot of oxygen, and guess what? This will increase the fire actually. Maybe dry ice, maybe water. Water is a good point actually. Maybe if we put water, this is good to suppress fire, and we do this in our daily life. When you go camping, and you want to put off the fire, I think the fastest way is just to bring some water and put it on top of fire, or maybe in Canada we put some ice on it, just or some snow. Maybe just bring some snow, put it on the fire, and this will put off the fire immediately. This is for heat. Now, fire blanket is not about heat. Fire blanket is about taking oxygen out of it. So let's take it one point at a time. If you want to take heat out of it, maybe we can use water. Maybe, or some of these cold components. But guess what? If you use water in data center, we will damage the equipment. So maybe this is not a good choice when it comes to data centers. Let's take the second component, the second leg for fire, which is the oxygen. How about if we decided to take oxygen out of the equation to take off or to put off this fire? We can use maybe blanket. Someone mentioned the blanket. Maybe we can use a blanket, but this is not scalable. We cannot do it in data center. Maybe vacuum air. Maybe we can use some chemical components that can maybe react with oxygen to take oxygen out of the room. Now, what is the challenge with oxygen? Now, if we take the oxygen out of the room, do you think the electronic equipment will be affected? No, but how about people? How about the human? How about people? Do you think people will like it? Yeah, human will have issue with this. But now they did some studies, and they tried to strike a balance. They wanted to see how much oxygen will take out to extinguish, to suppress the fire, but at the same time to be comfortable for humans. So they reach certain percentage. They said if it is between 15 to 19%, humans still can breathe, but at the same time, the fire will not be ignited. The fire will not have enough oxygen. So they try to reach some point where humans can survive and electronics will not be affected. And at the same time, fire will not have enough oxygen to stay or uh, to spread. We will discuss it more. Do the fire need more? Yeah, exactly. It needs more oxygen than human. So they decided to see something in between, that human is good and electronics are good, and at the same time you can put off fire. Now let's talk about the third component, fuel. What can we do to make sure that the fire doesn't have the fuel or the combustible material that may cause the fire to spread? Maybe we should not use wood in our data centers. Maybe we should not have any fuels nearby. We should make sure that fuels are contained within certain containers or safe chambers, and they are totally isolated from the rest of data center. So we need to control any fuels or any combustible material and make sure it is not all over the place. This is one of the mistakes they did in France. They have the decoration made by wood. So this is the main idea of this triangle. If you understand this triangle very well, if you know how to use it, this is the key concept of this lesson. If you understand this triangle and you know how to use it to suppress fire, I would say this is the main concept of this lecture. Now let's have a discussion. If you use this triangle for your advantage and use it to suppress fire, if you want to take heat out of the equation, maybe you need to use some water or some ice. If you want to use oxygen, maybe use some material that can take oxygen out of the equation. A fuel, we will discuss how to make sure the material we use in data center is not combustible, and what cables to use, what insulation. We'll discuss these in more details during this lecture. So why data center is unique? Why we have more risk in data center than in normal business area? There are a lot of reasons. First of all, we have a lot of power loads. Data centers actually consume more power than residential areas. I cannot remember the numbers, but sometimes one data center may consume more than maybe hundreds of houses, or maybe sometimes for mega data centers, they consume power more than thousands of houses. Data center actually consume large percentage of the electricity we generate. I don't have the numbers handy now, but maybe something within 10 to 20% of the power generated is utilized by servers and data centers and electronic components. So this is a lot of power. The other thing is we have generators in data centers, and generators need fuel. If you don't store them in a proper way, they are combustible and they may cause the fire to spread. Sometimes, because we have ventilation is sometimes against us. We have ventilation, which means fire can spread easily within data center, because with the flow of oxygen, the fire can also flow from one room to another. So this is something it might be against us in data centers. Yeah, for sure. Energy efficient equipment would help in everything, would help in reducing the power, reducing the heat, reducing everything. But guess what? We cannot have it to zero. We still have enough energy to overheat the devices and to cause fire. We cannot bring it to 50%. When they say the equipment is efficient, means we are reducing power by 10, 20% maximum. We cannot reduce it to 50% or 40%. So it is not that effective when it comes to fire, because we still have enough energy to overheat the equipment. The other source of the other risk in data center is cabling. And in many cases, the code for the cable, the PVC cable, do I have one of these? I don't have any one of them handy. The code for the cables is PVC, and this one by itself is combustible and can sometimes transfer the fire from one location to another. So we have a lot of sources of risk in data center, and that's why we need to give special consideration to fire safety when it comes to data centers. So to be able to control the fire, we first need to detect it. It is the first defense we have against fire, is to detect when we have fire. Now, first of all, the first defense is prevention. We should have proper storage for fuel. We should have enough maintenance. Then, in case of fire, we should have a way to detect the fire in the fastest way to be able to control it before it spread all over the building. There are different levels when it comes to fire detection. There are different levels that we should consider. First of all, as any business, as any other location, we should have building level detection, which means we need to have a strategy or a procedure to detect the fire in the building, in the normal NOC center, maybe where we have the employees. So this technology or this procedure is the same way we have it in any business. We should have something at building level to detect the smoke, the heat, the flame. It should be installed all over the building. It should be in the BMS integrated with the building management system. And this should be monitored for sure. Now, in some rooms, we have special equipment that needs extra care. For example, the server room. We may add additional detection, additional systems, more precise, more intelligent systems in server room, because this is where we have the main assets. So maybe we add more controls, more systems in server rooms because we have raised the floor and we have a lot of ventilation beneath these servers. We have plenums. We have sometimes false ceiling. So you need to have another strategy or another plan on top of the building level detection. In some rooms, you need to have another level per room to detect and to protect against fire. Maybe in these rooms, you install additional detectors. Maybe you should have identify any fire hazard within that room. Maybe you have chemicals for cleaning. Maybe you have you monitor these rooms with the heat monitors, the heat guns. So all these things can be monitored additionally in that room. In some cases, we apply also something at rack level. Maybe we have some racks that are important. They hold some critical sensitive data. Although we have backup for this data, but maybe we care about the safety of this data. Maybe we have some servers that are expensive. Maybe you have quantum computing in some locations. Maybe we have some HPCs, high processing clusters. So some racks may need their own systems that are dedicated for these racks. Maybe we add more sensors for heat, more detectors, more heat monitoring in these racks because they host some important material. So these three levels are on top of each other. So you need to have something for the building for sure. You add something for certain rooms because these rooms are special. They have special equipment or special plenums or special maybe resource assets. And we build the system that is designed for these rooms. And then in certain racks, we may add another layer of protection in these racks. So let me start asking now. We have our first question for today. It is our second question, maybe. Sorry, I did not select anything. It is my... Fire needs three things to ignite: oxygen, heat, and what else? What do you think? A, B, C, D. Yeah, exactly. D. Fuel. Oh, the answer is here actually. Do we need to hide this? Usually, I don't know why. So for you students, do you see this answer in your student guide? Do you see the answer also? Oh, really? So what is the point of the question? You have the answer. Oh, after answering or before? After you answer, okay. Okay, got it. Thank you. So if you answer wrong, still it is still there. Yeah, anyway. Okay, now we did all our precautions. We store the fuel in a proper way. We do our maintenance. Now we need to make sure we have the system to detect fire as soon as possible. We need to detect it immediately once it happens. Now, when it comes to detection, okay, when it comes to detection, we have different ways to detect the fire. We can detect the smoke because fire will always generate smoke. So maybe the fastest way to detect the fire is to detect the presence of smoke. If we have the smoke above a certain level, then we know for sure that we have fire. So this is the first way, is to monitor the smoke. What else we can monitor to detect the fire? What is the other feature of fire that we can use to detect fire? Oh, thank you. Heat, thank you. So we can detect the heat, but if the heat reach if we have the sensor in the ceiling and the heat reach the sensor, which one will come first? Smoke or heat? What do you think? Which one can be detected first? Is it the smoke or the heat? The smoke. So heat comes second. So first we should detect the smoke if we can. If we cannot, maybe we can monitor the heat. What else we can detect? What else we can monitor to detect fire? Maybe we can detect the flame, but this will be too late. If we detect the flame or the light, the flame of the fire, this will be too late, I would say. Yeah, thank you, Joshua. It is a flame, but I would say flame is too late. If the sensor can see the flame, then this means the fire is already in the place, and maybe it is already spreaded already, and maybe it is too late to suppress it. Maybe it is out of control already. But these are the three features of fire. These are the three features of fire that we can use to detect fire. So this is the early detection. This is the late, I would say, detection. And this is the early stages. This is the late stages of fire. Let's discuss these components one by one. So this diagram here, or this chart, show you different ways or different types of sensors available in the market. Do you think we may have other sensors that are not here? Yeah, there are many sensors in between, different models. We are discussing only the main ones that are available in the market, and every year you will have maybe new features and new things coming on. We will focus only on the main things available during the preparation of this course. Electrical surge can be detected easily, but this is not related to fire. You know, in most of the circuit breakers, where they detect the surge of currents of current to disconnect. We will discuss electricity more later, Kader. Um, Smelling the smoke, Victor, thank you. But remember, we don't wait the human, we don't the machine. We want this to be automated. We want the sensor to smell the smoke, even if there is no human, no people, no one inside the room. We want the sensor to do this, Victor, not for humans to do that. Let's start by this system one by one. Aspirator is the one that suck the air, send it to central unit to process it and detect any smoke. Smoke detectors are standalone devices. They can, similar to the ones you have at home most of the time. They are standalone. They can detect the smoke. They are analog. They detect the difference in smoke and can report it immediately. Conventional smoke detectors, they are connected by wire typically. They have certain threshold. They need more time to detect the smoke than analog ones. Analog ones can detect the difference in smoke. Conventional will have certain threshold. Heat detectors are efficient, but they are late because at that time the flames are already reaching the ceiling. Sprinkler bulbs, we'll talk about them in more details. They depend on heat. Once they are heated, they generate or they open and they start spraying the water. We will talk about VESDA. Thank you, Josh. You are ahead of us. Wait for us. So first of all, the fastest way to detect smoke is using aspirating smoke detectors or ASDs. ASDs in brief is something like this. Let me show you a video. I will use a lot of visual effects. I will use a lot of photos, videos, because fire system is something I would say far away from our daily life. I will try to show some videos because it would be easier for you to visualize the concept I'm discussing. So this is the ASD, which means a device that will suck the air, maybe aspirate the air, and send it to central unit to process it and detect the smoke. So they are some sort of smoke detection. They use smoke to detect the air, but they work as a system more than single sensor. So this is an aspirator. This is an open aspirator, maybe ASD, just to show you the idea. So they keep sucking the air. You'll know I'll make it without sound. It is noisy. Without it doesn't. You see, it starts immediately blinking. So this is an easy and fast way to discover fire. These devices typically work as a system. So typically they work like this. They have a lot of these ASDs all around the room. They are connected to central unit. They send the air to this central unit. The central unit will detect. So once there is any smoke, the smoke will go over the pipes to the central unit, and the central unit will detect. And it is only detection right now. We will do this. This is not for suppressing the fire. This is for detecting the fire, which is the first step in suppressing the fire. This is a system now. It is not easy sometimes in houses to build full system like this. Sometimes in houses, they want it to be maybe standalone. And there are different regulations for different states, for different countries. In my place, the standard is conventional ones that connect by wire, and they run as a sector in that they may have more than one zone in the house. But this is another thing for maybe business areas. I will give you the link, but when I give you the link, this is mainly for certain product. It is not endorsement for that product. It is only for you to read it and understand the concept. Because at the end, all the sensors belong to certain product, certain vendor. So we need to read for different vendors to understand the concept. But it is for me, when I give you the link, it is not endorsement for that vendor. It is only for you to read about the concept. So these are the ASDs. They collect the air from different ASDs, and then it will be processed in that central unit that will be used to detect the fire. Now, ASDs are somehow traditional. They are around since maybe 1970s or 60s. And the new version of them is VESDA. Who mentioned VESDA? Someone said, yeah, Fredo. Yeah. So, you know, it looks like some of you guys are expert in fire systems more than me. Sometimes maybe some of you worked in maybe construction, maybe they worked in site preparation. And in this case, you will be experts in fire systems more than any data center technician, because you deploy them, you implemented them. So VESDA is some sort of advanced type of ASD that can detect the fire faster, more precisely, and give more accurate results than ASD. So next in the chart, so we discussed now these two. We discussed the ASD. And VESDA is some sort of advanced ASD. So we discussed these two. Next is analog smoke detectors. Analog smoke detectors will depend on smoke also. They detect fire by detecting the smoke, similar to ASD, but they are some sort of standalone devices. They have the detection within the unit. Some of them, they use lasers. Some of them, they use different techniques to discover the existence of these particles in the air. And analog will detect any variation, any big variation is in smoke level, and will report it immediately to the alarm system. On the other side, conventional smoke detectors, they depend on a threshold. They have certain threshold. If the threshold is exceeded, they immediately sound the alarm or report the incident to alarm system. Fire system works as a system. There are sensors, there are sprinklers, maybe there are central unit. So there are multiple components managed by one central unit. So we are talking only about detection part of it. There should be also suppression part of it. Now, the other part of detection is heat detector. And as we discussed, heat comes after the smoke. So maybe you should have maybe different levels. Maybe you can have smoke plus heat in the same room. It comes to the designer who designed the system, and the designer should be expert enough to decide what kind of detector is the best for that location. For us, we need only to understand the difference between them, the names, but at the end, you will follow the design that is already in place in data center where you work. Heat detectors will detect heat as per the name, and they will report to central unit when the heat exceeds certain level. Some of them, they also they see the rate of raise. So if this is your temperature, some of them will fire the alarm, will trigger the alarm when the heat is increasing rapidly or increasing rapidly. Some of them are threshold based, which means they will report the alarm when you exceed certain threshold. Threshold based means once you exceed certain threshold or certain temperature, this is called fixed temperature heat detector because it's based on temperature. The other one is based on that change. If there is rapid change in temperature, then they will report it to the system. So once we detect the system, once we detect the fire, we need to suppress the fire. It is now detecting is important because we want people to leave the building. It is important to detect the fire as soon as possible to give a chance for people to leave, to give chance for the fire department to be alarmed maybe and to send the brigade. But also there should be suppression system. And if you remember in the data center in France, they did not have suppression system. There was no system to suppress the fire. They have only detectors. They depended on the fire department to send teams to suppress fire. They didn't have their own system. While in proper cases, there should be a system for the fire suppression. And this is the sprinklers. We will talk about sprinklers more in the coming slides. Another way that you can use to prevent fire is to have heat scanners. Just imagine if in France, if someone is doing proper maintenance and if they have this tool, this is the UPS will not fail in 1 hour. Typically, the UPS will start heating in certain part where there is some malfunction electronics. And during that time, you have the chance to detect the malfunction before it became fire. If you have this heat scanner, maybe you can just scan it. And when we talk about preventive maintenance and the regular checks you need to do, one of them is to monitor the equipment with a heat scanner to know if there is any extra heat, if there is some anomaly, if there is any abnormal heat in certain part of the data center, or maybe if there is one of the routers or switches or servers generating more heat than usual, then you know something is wrong and you report it to your manager, or maybe you take action. So if they had this equipment, they could have detected the cause of fire before it happens actually, and they could have protected it. I don't know. So this is a way to visually know if there is any extra heat in certain area. So question, why are early detection and quick notification so critical in the data center? What do you think? Why we need to know about fire as soon as possible? Why are early detection and quick notification so critical in data center? To save property and lives, I would say saving lives, to give people a chance to leave quickly, and maybe to control the fire at early stage, maybe. Yeah, save lives, assets, maybe to control the fire before it spread actually. Now, when we detect the fire, means it is there. So when we detect it, mean it is already there. We have fire already, but maybe we will be able to control it easier when it is small before it spread all over the place. Let's finish this and then we'll have a break, and after the break we'll continue. Let's finish this part. Now, when it comes to the system, the fire system, there are multiple components. Let me show you something. Where is that thing? It's not here. No, fire emergency. If there's any fire, there should be an alarm. There should be a siren or alarm that inform everyone of the existence of fire. The fire or the alarm can be triggered in different ways. First of all, we have the central unit. And we have our detectors. Detectors can be smoke detectors, can be heat detectors, can be flame detectors. And these detectors will trigger the siren, the alarm. This is the alarm, which is this one. Immediately once fire is discovered or detected. In addition to this, there should be some manual. Maybe you as a human, you can see the fire, but it is not detected yet by the system. Do you want to wait for the system to detect the fire? Or maybe there should be a way for people to report the fire immediately and to alarm everyone. Yeah, thank you, Joshua. So there should be a way for manual triggering the alarm. And that's why typically in the fire system, you'll find some manual call point. Now, what is the challenge with these points? So some people, if they are not in business area, if they are residential area, people may trigger the alarm for false positive. They think there is fire, but there is no fire, maybe by mistake. Now, typically they cover them by glass to make it difficult for someone to break the glass and trigger the alarm. So they make sure they will be triggered only in serious conditions. But there should be some manual alarm triggering to make sure that people have the possibility or the chance to trigger the alarm. Now, all these detectors, suppression, sprinklers, manual alarm, manual call point, and alarms, all of them should be connected to one central unit. We call it fire control unit. This unit is the brain for the system. It evaluates all the signals. It detects the location of the fire. Typically, the fire system will be divided into zones. So it will detect the fire comes from what zone. It detects the sensor who discovered the fire. It gives you indication of the location of the fire. It triggers the alarm. It triggers the suppression system for that area. So there should be a brain or control unit that manages all this. And this control unit should have input from the fire detectors. They should have input from manual call points. Maybe they have some inputs from BMS system, from other inputs. They process this, and then they give alarm to people to leave. These alarms are mainly for people to leave the area, evacuate immediately. Maybe there should be some fire suppression system. So they initiate the fire suppression system. And then maybe they contact the fire brigade immediately, the fire department or the fire station, to ask for help in addition to the fire controls. So this control unit, you need to know the location for this unit. You need to know what different sources or what different peripherals available. You need to know what actions are taken, what suppression system you have, the location of the alarms, and how to contact the brigade immediately. You need to know that, although the central unit is doing this for you. Let's say I shut off the power emergency cutoff. Typically it is connected by UPS. It has its own power. So we will discuss this maybe. Many of the fire suppression systems, they can function without power at all. Even if there is a blackout, no power at all, there should be a way for these systems to function even without power. Even the alarm should be somehow connected to UPS or maybe some additional power sources to make sure it is not affected by the outage of power, because it is typical for fire to be initiated by power failure and or power maybe malfunction, and then the first thing to be affected is the power system. So these alarm systems should function without the commercial power, without the normal power in the building. They should have their own maybe backup power or maybe DC powered or battery powered system. Oh yeah, I agree with you. Sometimes people in panic is to avoid panic. We need to have drills, and we will talk about the drills more in the coming lecture, in the coming slide. So now let's have a break. After the break, we'll talk about the cables. We'll talk about the suppression, the compliance. Any question before the break? Any comment? Anything before the break? Okay, let's have a break for 15 minutes, and we meet again after. Okay, everyone. Welcome back. I hope you enjoyed your break. Let's continue from where we stopped. Just to confirm, can you hear? Let me share, and then I'll ask the same question as always. It happened to me many times. I start talking, and then I discover that everything appeared good, but people cannot hear me. Just to make sure you can hear me, you can see my video, and you can see my screen. And the screen shows cable jackets, right? Great, thank you. Just to confirm, this is our virtual life nowadays. We need to confirm things. Okay, so we will focus now on some of the aspects that are related to data centers more than any other location, which is cables. We will discuss some of the components in IT system that cause the fire to spread within data center. And one of the main ways for fire to spread is the jackets of the cables. These jackets are made of PVC, and this PVC is combustible and it can spread fire. So there are three types of PVC, or let's say for cable jackets. First of all, we have the normal one. We call them communications multipurpose cables. So the abbreviation is CM, multipurpose. So let me make sure the correct abbreviation. So we have the general ones, which we call them a CM, communication multipurpose. And guess what? These ones can spread the fire. They are combustible. They can get the fire and spread it from one location to another. The other type is CMR. R stands for riser. Riser is the space that goes between floors. These ones are better. So this one is bad. This one is better because it can resist the fire to a certain extent, but it is more expensive. On the other side, CMP is the best when it comes to resisting the fire, but it is more expensive, more and more expensive. So it is the better, it is both better and more expensive. This one is cheaper, but less common, or less is bad when it comes to resisting fire. So somehow this is the visualization. In your normal office environment, you would use general use, which is CM. If you have any riser that goes between floors, this one is more fire resistant, and we call it CMR. The R stands for riser, which is the space or the shaft that goes between floors. We want to make sure that the fire does not spread between floors, and we want to make sure this cable is selected in a way that can contain the fire. If we have any plenum is somehow risky. What is the issue with plenum? We said that there are three components that can ignite the fire. We have the oxygen, we have the heat, we have the fuel. Which one of them exists in this space and cause it to be one of the main sources of fire spreading? Airflow and oxygen, yeah, because we have the airflow that goes between rooms in the same building, and in many cases, the airflow is circulating over this plenum. So if we have any fire here, it can easily spread to the other rooms in that floor and even go between floors. But the difference between riser and plenum, here we have a lot of airflow and a lot of oxygen, which means it is the best location for fire to spread. If we have this cable jacket represent the fuel, if it is combustible and it represents the fuel, so we have the oxygen, we have the fuel. All what is missing is the heat. And once we have any heat or fire that comes from other location to here, we have all the components. If there's any, if any cable here catches fire, then we have heat, oxygen, fuel, the best combination for fire to spread all over the building. We want to break this circle. We want to remove one of these legs of this triangle. We cannot control the heat. There's a chance that the fire will catch from other location, will come here. We cannot control the oxygen because we need to have the airflow here. So we need to make sure whatever we use in this space doesn't spread fire from one location to another. And that's why this should be highly rated against fire, CMP, P for plenum. Now, if this one is the best, why don't we use it everywhere? Why don't we just use this cable in all locations? Cost, it is a matter of cost. So if it was up to me when they design cabling, I would say go for the most expensive one, make it safe all over the place. But this is not the choice for many business owners. They want to use it only when needed. So they use this if the cable goes above the plenum. So these are the three types of cables that exist and different ratings. So we have the CM, the CMR, and the CMP. And because this concept is important and this concept is related to you as data center technician, let's watch this video also. Did I share with sound? Let me make sure I share with sound. Sorry for I'm shared with sound. So because this concept is important to data center technicians and you have influence in this subject, let's watch this video. It is a short video.
Hello, and this is current environments and situations in terms of fire safety and fire ratings. But first things first, let me talk about PVC.
Okay, what is the plenum? Good question, thank you. Plenum is the space that is between the ground and the raised floor, or between the false ceiling. And so any space, empty space. So this is the room from the side. This is the raised floor. If you have raised floor, this is called plenum, because it is the empty space between the raised floor and the ground. If you have false ceiling, this is space between the false ceiling and the actual ceiling is called plenum. So the space, the empty space above or below. Thank you for this question, Stefan. Sorry, I forgot to mention this. So this space is somehow where we have the airflow. We design our ducts, and we have the cold air coming to the room below the raised floor. So this is the actual ground. This is the raised floor. This space is plenum. This is the false ceiling. This is the actual ceiling. This is the plenum. We use it typically to lay cables. We use it to circulate the air within the room. Good question, thank you.
A common material which makes up for Ethernet cable jackets. Vinyl chloride is
so
very.
The PVC. The PVC is somehow considered some sort of fuel or combustible material.
Compound for wire insulation and a cable jacket for its durability, strength, and resistant to chemicals and water. This type of PVC is flexible, not rigid PVC like PVC plumbing pipes at home. Sometimes Ethernet cables are labeled PVC. PVC cables can produce smoke and fumes, toxic and dangerous if caught in a fire. But PVC cables are made differently in terms of fire safety and fire resistance. They often have CM, CMR, and CMP ratings as defined by National Electrical Code.
So we have 3 ratings. We have CM, CMR, and CMP. Which one is the general one? Which one is the general purpose one? Which one of these 3 is the general purpose? This one, CM. Which one is designed for the riser? Which one is designed between floors? CMR, the R stands for riser. Which one is designed for plenum? CMP. Yeah, the name is clear because the last letter mentioned the location where this should be installed.
Now let me use an example to demonstrate these 3 different fire-rated cables and where we normally use them. Here is the typical residential home. The airspace between the structural ceiling and the dropped ceiling is called plenum, where the best fire-rated cable should be used. But we start with the CM-rated cable, like this patch cable running from the workstation to the wall outlet. CM-rated cable is mostly commonly used at home or in office, but it produces a lot of fumes and a big flame when caught in a fire. On the right side is a CMR-rated cable that can be installed between floors of multi-story building. It's better than CM-rated cable, but it still produces smoke and fumes in a fire. The best fire-rated cable is a CMP-rated, which.
So CM is a lot of fire. CMR is less fire. CMP is the least.
Is normally installed in a plenum area above the drop ceiling. This is general view. Now let me talk about each of these 3 fire-rated cables in detail. CM stands for Communications Multi-Purpose. It's equivalent to CMG for General Purpose.
So sometimes we call it CMG. So this is the CM.
They are most commonly used commercial-grade communication cables. They are used at residential home, an office, or single-story commercial building. Examples: the patch cables running from workstation to wall outlet, patch cables from switch or router to patch panel, or the cables installed inside the wall where the fire code is not strict. They can emit toxic smoke and fumes when caught in fire. The better fire-rated cable is CMR-rated. CMR stands for Communications Multi-Purpose Cable Riser. It also refers to the riser-rated cable that can be installed between floors of a multi-story building. It's better than CMG-rated cable, producing less smoke, less flame, but it's more expensive than CM or CMG cable. Most installations between floors of a building use CMP or plenum-rated cables nowadays.
Now, for your question, CMP is maybe the next. So if it is CMP, it is already CMR. It is above CMR. So CM is the minimum. CMR is better. CMP is better. So if it is CMP it is already above CMR. It is CMR plus. So if it is CMP, it is already achieving the qualification of CMR plus much more. So CMP is all of the above. It is above CM and CMR. Yeah, in this case, you would go for the best for CMP. I don't know the regulations. I don't memorize all of them, but I would say, without reading the full regulations, I would say go for CMP. If the cable will go between floors and it goes above the plenum, I would say go for CMP. But you need to verify with your local regulations and the standards. Now, between floors, do we run UTP or different cable? Do you think we run UTP typically between floors? Do you think UTP run between floors? What type of cable we run between floors usually? What do you think? Do you think UTP copper is the best? No, typically we run fiber. So typically the cable between floors is not copper, is not normal copper like this one. It is not like this one. It is not the RJ45 between floors. We use fiber typically, but fiber also has jacket, and also it follows the same categories. But just a side note, typically we use different cables between floors. Typically fiber, and it should be also coated by fire regulated or fire resistant coverage or jacket.
CMP stands for Communications Multipurpose Cable Plenum. It's also referred to as plenum-rated cable. Plenum refers to space above the dropped ceiling or under a raised floor. These spaces are prone to fire. Air from plenum spaces circulates rapidly through a building. CMP-rated cable jacket is made from either a low-smoke PVC or PEP. It's slower to burn, it produces less smoke, less fumes, it produces no or little toxic smoke when they burn. Plenum-rated cable is of a higher quality than both CM or CMR-rated. PVC.
So this is the brief about the three types of cables, and you need to know the difference between them. You need to know what type of cable is used in your data center maybe. And if you have that choice, if you have the decision, you need to make sure that if you are the one to decide, you need to understand and select the one that is proper for your deployment. Okay, now let's move to the next subject, fire suppression. So now we detected the fire, but this is not enough. We need to have a system in place to suppress the fire. And we want it to be automatic. We want it to be on site. We don't want to wait for the fire department or fire truck to reach the location. We need to have a system in place to suppress fire, and this is what we will discuss now. So why do we need to have a full system, fire suppression system? Because we need to have all the components connected. We need to make sure the fire suppression system include detection system, because it is the starting point. We should detect the fire to suppress the fire. We need to make sure whatever system we have, whatever chemicals we use are safe for humans. We want to make sure that we avoid halon. In old days, halon was the standard, or was actually the main way to suppress fire in data centers, but it was harmful to humans. So we don't want to use halon anymore. We want to use different material that maybe decrease the oxygen without being harmful to humans maybe. We want to make sure that whatever we select for fire suppression is also safe for equipment. We have electronic and electrical equipment in data center, and these equipments are the main assets in data center. So we want to make sure whatever we use is safe for them. If we use water, actually, this is a big issue because water will damage electronic and electrical components. What is in water that makes it bad for electronic components? why water is bad for any electrical system or electronic system. Conductive, thank you. It is conductive, thank you, Christopher. So water is conductive, it conducts electricity, which means our electronics are designed in a way, maybe we have diodes, maybe we have transistors, they are designed to make the traffic flow in certain way to make or to apply the logic we want. What if we have water all over the place? It will do short circuit, it will connect everything to everything, and all the electronic device will be damaged because it is some sort of short circuit connecting any to any, and this will cause the device to be damaged. It is short circuit, thank you, this is the term. So thank you, Patrick, it makes short circuit. Thank you, Christopher, it is conductive. If we want to replace water with another substance or another chemical, do we want this chemical to be conductive or non-conductive? None, for sure. We need to select something that doesn't conduct electricity, and this is one of the main features we need in any substance or any chemical that we select for fire suppression. So it should be safe for equipment, which means it should not be conductive. It should be safe for the environment, for sure. And typically we have certain metric, we call it GWP, global warming potential. And in this case, we need to make sure whatever we select is safe for the environment. For example, if we select something like FM200, this has a bad GWP. So we need to select something that is safe for the environment. Now, to your suggestion of plastic, remember, what is the goal? We want to suppress fire. We want something that can suppress fire and at the same time don't conduct electricity. So we need to find a chemical or substance or material that can whether take the oxygen out of the space, take the heat out, and at the same time not to be conductive. So what are the examples we have in the market nowadays? We will talk about them in the next slide. So in many cases, people apply what we call dry pipe. Dry pipe means the sprinkler system doesn't have liquid, doesn't have water, doesn't have any fumes by default, because we don't want the system to be bad. What if we have a sprinkler system or fume or whatever system that is designed to detect and protect from fire, but guess what? This system itself is leaking. So it may cause harm more than benefit if it is leaking. So they want to make sure whatever system we use dry pipe. In normal state, we don't want the system to have the chemical, whatever chemical we use, we don't want that chemical, the water or the fume, to be inside this space or inside these pipes during normal operation. We implement what we call as dry pipe sprinklers. We will talk more about them in the coming slide. When it comes to selecting the chemical, we want to use something we call clean agent. Clean agent means this device should be non-conductive, and also at the same time, it should be clean agent means that the material is non-conducting, doesn't leave any residues. So when we spray it on the material, it vanishes, it disappears, it doesn't leave any residues. It doesn't damage sensitive equipment. So this, we call it as clean agent. We need to find material that achieve these three: no residues, no electricity, no damaging, and should be non-toxic for sure, not to harm humans. So these are the conditions we have. These are the requirements we have. How are we going to achieve them? Let's see. We need also to have some sealing between rooms to avoid spreading of fire, spreading of air. We want to limit the fire, to control the fire. So all these, some of the components we need to consider in this fire suppression system. We will talk about all of them. Thank you, Ali. We'll talk about, not all of them, we'll talk about Novec 2030, we'll talk about argonites, and I am not, I would say I'm not expert in chemistry. I will mention the names, but I don't know the components inside these names. It is not required from you to be a scientist in chemistry, maybe, or to know. You need also to know what you need to know just to manage your work and to be able to monitor the system and to maybe make sure it is functioning as it should be. It is always good to have green energy to avoid anything that may exploit the environment or affect the environment or harm the environment. And sometimes we use the solar system to feed the fire suppression system. Now, when it comes to sprinklers, which are the devices that spray the water typically, there are two systems. We have dry and wet. Let me show you something that may help. So there are two ways to achieve fire suppression. First of all, typically let's say we use water or mist maybe to extinguish the fire or to suppress the fire. The first option is maybe we can have the water running in the pipes all the time, and the sprinklers are ready. Once there is a heat, the sprinkler will immediately open and spray the water all over the place. This is called wet system, which means the water is ready, immediately spray the water. The other side is, what if we have dry pipe and the sprinklers are there? In case of fire, only in case of fire, the system will detect the fire, will open the valve, will let the water go inside the pipes, and then the sprinklers should have the heat to open, and then we spray the water. So first of all, which one of them is faster? In case of fire, which one of them will be faster to start suppressing the fire? The wet, yeah, for sure. It is a bit faster. But what are the disadvantages? What are the risks of wet system? Why we want to avoid wet system? Leak, yeah, this is one point. And what else? Sometimes if you believe the room will be freezing, which is not the case in data center. Data center will never go below below 18 Celsius, because we have a lot of heat generated inside data center. So freezing is not the main concern for us in data center. But typically they use the dry also if you believe this area will go below freezing point at certain time. So these are the two systems, dry and wet. In data center, which one we prefer in data center? Which one we prefer in data center? We prefer dry, correct. So dry pipe, they only contain the water when they are activated. Only at that time the valve will open. The valve will open and will start spraying the air. On the other side, wet will have water all the time. Now there is an advanced way of sprinklers. Instead of using water, they use water mist, which is less, I would say, damaging maybe to the equipment. They will just spray concentrated water mist. This mist is very effective in controlling the fire, reduce less water than the sprinklers, and also the water can maybe control the fire faster. It has a system to maybe also suck the smoke. It has a system to take the extra water. So it is a whole system that can do all this. And guess what? In case of no power, they have what we call as gas pump units. These units will use the pressure to push the the chemicals or the material or the water inside these sprinklers and will spray the water in case of fire. So these are some of the components we should keep in mind when it comes to selecting the system. Agent. Now, there are three systems actually we'll talk about. I'd like to show you, I will not run the full video, I will show you just the samples of it. So these are the systems we typically run, the wet and the dry.
Types. There are four main types of systems: wet pipe system, dry pipe system, pre-action system, and deluge system.
Now, we will not discuss this in this lecture. We will discuss this. Now, what is this? What is pre-action? If we use a dry pipe system, there should be a trigger for the valve to open and to let the liquid or let the suppressant or let the water go inside the system. So what will be the trigger for this? We call the pre-action. What will be the action for the valve to open? Is it enough for the heat to be detected, or maybe it is enough for the sprinkler to detect the heat, to open and then open the valve? So the pre-action means there should be a pre-action for the valve to open and to fill the pipe with water to expedite the process. We will not discuss the fourth system. We don't care about it. So this video may help explaining the idea. I'll run it quickly. It is a few minutes only.
Wet pipe sprinkler systems. Here are the components of a wet sprinkler system. In addition to the water supply, piping, and sprinklers, these systems have backflow prevention device, control valve, main drain, fire department connection, water flow alarm. Wet pipe sprinkler systems always contain water in the riser and piping. As soon as a sprinkler head activates due to the heat of a fire,
so it is heat detector. Once there is a heat, the sprinkler will open and the water will be sprayed immediately within the data center.
Water is immediately discharged through the open head. Dry pipe fire sprinkler systems. Dry pipe systems are very similar to wet pipe systems with one major difference. The pipe is not constantly filled with water. Instead, the water is held behind a dry pipe valve, usually some distance away from where the sprinklers are located. Like a wet pipe system, when the temperature at the ceiling becomes hot enough, the glass bulb or fusible link of the sprinkler breaks. However, in this case, water isn't immediately available because the pipe is not water-filled. Instead,
so as mentioned, so during the heat, the sprinkler still heat, it detects the heat. When there is a heat, it will open. When it opens, the pressure of the gas pressure here will be low. So this will trigger the valve to open and then will push the water inside the pipe. This is the dry.
Air is released from the now open sprinkler head. This creates a drop in pressure, causing the dry pipe valve to open and water to fill the system. Water will then flow from the open sprinkler head. Since there is a delay between sprinkler operation and water flow, the size of dry pipe systems is limited. The size limitation is intended to minimize the amount of time water delivery is delayed. A dry pipe system is a great option for unconditioned spaces or locations where the temperature of the space cannot be guaranteed to be high enough to prevent water in the system from freezing. Pre-action system.
Now, pre-action is something on top of dry. We want to have a trigger for the valve to open. At what time? So in the dry by default, in the dry system by default, when the sprinkler detect heat, it will open and will bring the pressure down, will open the valve. But sometimes we want to have more control, and this more control is called pre-action.
A pre-action type sprinkler system employs the basic concept of a dry pipe system in that the sprinklers are closed and water is not normally contained within the pipes. One difference, however, is how water is admitted to the system. Water introduction into the system's piping is initiated by opening of a normally closed, mechanically latched valve known as a pre-action valve. Means of operating the pre-action valve depends on which of the three types of pre-action systems, non-interlock, single interlock, or double interlock, is installed. Pre-action valve operation is dependent upon one or two of the following events occurring: sprinkler activation and detection device activation. A non-interlock system requires only one of either event to occur before water is admitted into the system. A single interlock system is activated only upon the event of detection device activation. However, in a double interlock system, the two separate events must happen before water is admitted into the system: sprinkler activation and detection device activation. Deluge systems.
I will give you the video in the chat, and maybe someone can put it in the resources if you want to watch it. I like this video. It is long, but it gives a lot of details. Now, fire system is one of the subjects that I would say a bit challenging because we don't deal with them on daily basis, and they are not our main specialties in some cases. So maybe you need to watch videos to visualize, to understand the system in a better way. Yeah, and that's why maybe I included more videos than usual, because I'm trying to visualize to make the system more understandable, maybe. Okay, so let's move on. And now we reach the fire suppression. We talked about sprinklers. We talked about this, and now next is the clean agent. Now we want to use a material that is human-friendly, electronics-friendly, environment-friendly, and we call them sometimes clean agents. They should be non-conductive. They should be they should be non-conductive, and there are different chemicals that can achieve this. We have inert gases, FM200 and Novec 1230. Now I have a table that compares the three of them. Yeah, these ones. So let's take a look into the table. So we have different clean agents. We have the Enrigon. We have the FM200 and 3M. Now, which one of these is most important to you? Let's start with one of these features that is most important to you. What do you think? Which one is most important to you? Let me see the first answer. So, best use case. Yeah, best use case. So all of them can work into the center, actually. For us, they are the same when it comes to use case. Let's say human safety. Human safety, which one is the best for a human? It is the Novec 1230. It is non-toxic, safe, but this one is also safe. So both of them, they achieve. This one is taking the oxygen out, reduce the oxygen, and some people may feel uncomfortable in this case, but it's still safe, but it brings the oxygen level lower than the usual, but still within a range that is breathable for a human. Residue cleanup, all of them are good. You guys are selecting the features that are similar. Let's see what is the difference between them. Environment impact. This is a difference between them. This one is eco-friendly. This is low. This one is bad, maybe. So this one used, yeah, somehow they are similar, but I would say this one is more yeah, this one is more friendly to people. This one is more environmental friendly. So somehow maybe I would say I would vote for this one, maybe. In many cases, it is similar to FM200, but more environmentally friendly than FM200. It can achieve the same thing. It doesn't take oxygen out. So yeah, these are the different ways. The good thing with the systems that take oxygen out, they are fast because they immediately take the oxygen out of the equation, and the fire will find no way to keep going. And this is maybe fast, but the impact will be in humans a little bit because some humans will feel uncomfortable when there is a drop in oxygen. I have never tried this drop in oxygen, but I don't feel comfortable knowing that the oxygen will drop from maybe 20 or 22% to lower value. because this may cause some impacts on humans. So for example, I want to show you some numbers. This is one of the systems, they call it fire pass. They say that they reduced the, they say that they reduced the oxygen from 20 to 15%. So this is one of the solutions that use oxygen reduction. They say their solution reduced the oxygen level from 20 to 15%, and they say humans can live without issue from 12 to 16%. So they say we are within the safe range for humans, but it is good to have some oxygen masks. If you plan to use this solution, they say maybe you may consider oxygen masks for people who feel who have issue breathing. But this is one of the oxygen reduction solution. The normal room should have 21% maybe. A human can live anything from 12 to 16 without issues. And they say they bring the oxygen to 15%, which is enough to suppress the fire without affecting humans. So this is the formula they use. They want something that doesn't ignite fire and at the same time safe for humans. So these are the three agents we'll discuss: inert gases, FM200, and Novec 1230. The energen or Ansel energen is actually a clean agent that uses three inert gases, nitrogen, argon, and carbon dioxide, and it lowers the oxygen. So this one lowers the oxygen level, and it suppresses the fire by using this, by taking the oxygen out of the equation. If FM200 is another way, it uses heat removal. So this one takes the oxygen out of the equation, the other one takes the heat out of the equation. The third one is also heat. Yeah, the Novec 1230 is also heat-based. Let me see the table again. Yeah, it uses also, it absorbs heat. So as you can see, the triangle, the fire triangle is the base for everything. If you understand the triangle, if you understand the three legs of this triangle, the oxygen, the fuel, and the heat. So it's all about this triangle. This one takes the oxygen out of it. The other one takes the other two takes the heat out of it. So why would we go for clean agent? Because they are safe. They don't damage the equipment. They are non-conductive compared to water. Water is conductive. Water can damage the equipment. These are non-conductive. They don't damage the equipment. They don't leave any residues. So they are clean. That's why they call them clean. You don't need to clean because they don't leave any residue after them. You don't need downtime. You need just to maybe shut the equipment or maybe stop the equipment during the process, and everything will come back as normal, maybe after some checkup, maybe. They act very fast by taking the oxygen or heat out of the equation, and in this case, the fire will extinguish immediately. Now, there are two types of fire suppression, let's say. There is the small scale, the fire extinguishers, which are these cylinders that we have in every house, in every kitchen. They are mainly handheld devices for local use only. They are not for a system, not for the center. They use a clean agent. We can use clean agent also in suppression system. We can have it in data center where we have a full system with detectors, with sprinklers, and the sprinklers will spray clean agent instead of water. So these are the different ways for extinguishing. Do you think we need both of them? Do you think in data center we need both or only one? Do you think both of these are needed, or it is enough to have one of them in data center? Yeah, you need to have both. Even if you have a system, you need to have fire extinguishers in some key locations to make sure that people have the option to extinguish fire if needed. Now, in many cases, the rule says for people to leave immediately, not to worry about extinguishing the fire or suppressing the fire, because the human safety comes first. In many cases, they ask you just to leave. But yeah, you may have them to ask. So sometimes even leaving is difficult. You need to have a way to suppress the fire. Now, when they do fire drills, typically there's one person that lead the process. Do you know what they call him? What they call that person? The one who lead the process and make sure that communicating with people how to do the drill, how to leave the building. They call them maybe commander. Sometimes they call them not that. They call them warden sometimes. Typically in workplaces, marshal maybe, yeah, marshal sometimes they call them. But in my university they call them warden. So sometimes you volunteer maybe to become the warden, and then you are the one who gives the instructions in case of fire. I don't know what is the attractive in this position, why people volunteer to become wardens maybe, or marshals. What do you think? Do you think you will be interested to be the fire marshal or fire warden? Do you think you will volunteer to do this job maybe? Typically, there is no financial, I would say, advantage. It is something that some sort of responsibility. Yeah, different people have different opinions. Some people think it is something good, something nice. They feel maybe respected. They feel important. They feel useful. They feel giving back maybe to the community. So it is some sort of different opinions, but different workspaces have different names for this role. Some people call it the warden. They call it, I believe. Yeah. Some people call it marshal. Some people call it commander. Maybe he's the person who manages the drill and not only the drill. Even in case of fire, he is the one to be responsible. And typically, they have the vest. They have some extra light. They have some extra tools to control and to manage and to communicate with others during any fire. And they practice very well during fire drills. Now, question: how could clean agent gas potentially impact servers and other IT equipment? What do you think? It is non-conductive, so maybe. Do you think there'll be any bad impact of this agent on equipment? I believe no, but maybe some residues will stay. Maybe if there is plenty of it. Maybe physical damage, maybe because when pushing the liquid, it may move some parts, maybe. Yeah, there's always a chance. If you have fire, there's a chance of damage. You cannot guarantee 0% damage. Remember, there's a lot of moving parts during fire, a lot of liquids or fluids sprayed all over the places. Maybe some mechanical parts will move, fire will move. Yeah, you don't know, but I would say maybe typically there should be no impact. Maybe in the gray space will have some impact. Now, a question: why it is necessary to use a clean agent fire suppression in data centers? What do you think? A, B, or C? It is C. Agree. So water could cause suffocation? Not really. We are not drowning under the water. A clean agent, is it cheaper? Not really. It is more expensive than water for sure. If water is used, it will damage the equipment. Yes, correct. Water will damage the equipment if used to suppress fire. Now, another technique that we should use or should have in the data center is room sealing. Why we need room sealing? Because fire actually spread with airflow, and mainly if we have airflow with in plenum and a lot of oxygen moving around, then this is the best circumstances for fire. If we have heat, if we have fuel, and we have the oxygen with airflow, this will cause the fire to move from one room to another. We want to control the fire. If this is our data center, we want to make sure if there is any fire in any location, we want to control it. We want to seal that location from others. But on the other side, we have ventilation, we have a plenum, we have a lot of open spaces between these rooms. So if you want to be able to control fire faster and to limit the spread of fire, we need to have some sort of sealing between rooms, and mainly in the important rooms. If we have rooms that are prepared for emergency, if we have several rooms that we want them to be safe in case of fire in other places, we want to have these rooms fully sealed, so in case of fire in another rooms, the fire doesn't extend to these rooms. To do that, we need to have some sort of containment barriers between rooms. If you are in a hospital, you see always between different departments in the hospital, they have fire-rated doors, and even in the houses, the door that connects the house to the garage typically is fire-rated, which means they don't allow fire to go. And also there should be something similar in the plenum. There should be something to block the air between these two spaces, to consider them sealed. It is not enough to have the door fire rated. They should be sealed even in the plenum, above or below, to make sure the air doesn't flow between these two locations. So this is what we call as room sealing. It is mainly to have some airtight rooms to limit the potential damage, to control the spread of fire. And somehow the HVAC should be integrated with this. In case of fire, the HVAC maybe should stop functioning, maybe, to make sure that the HVAC is not participating in spreading the fire. Because just imagine if you are trying to control the fire, and at the same time your HVAC is circulating the air within the building, then your HVAC will circulate the fire with the air, and it will be part of this spreading of fire. So the system should be all integrated. There should be a way to shut down the HVAC in case of fire detected. And this is somehow to minimize the spread of fire and minimize the damage. Oxygen reduction, as we discussed, we have the 3 legs of the triangle. We always try to take one of them out of the equation, and oxygen is one component. If we can reduce the oxygen to the level that doesn't harm humans, but at the same time can cause the fire to suffocate, maybe, or to maybe to suppress, or to stop the spreading, or to extinguish the fire, then this is what we need. This should be based on science, should be based on calculation, should be monitored. And I believe in these cases, maybe there should be oxygen masks available for people who maybe feel uncomfortable, or maybe have any sensitivity or any health conditions, and they need more oxygen. Maybe there should be a way for them to breathe. But the concept is to calibrate and make sure the humans can breathe. Provide some air masks maybe for people in certain situations, and make sure that you only reduce the oxygen to the level needed to suppress the fire, but still enough for humans to breathe. Yeah, thank you, Anibal, for the answer. Now, we need fire safety authorities. Why do we need fire safety authorities? We all know what need to be done. All data center owners know what must be done. Why do we need authorities to put regulations? What do you think? Do we need authorities to put regulations to force certain rules on data center operators? Or maybe everyone knows what is right, what is wrong, and no need for these guys. They just make our life difficult, complex. We better implement the best for our interests. Do you think data center operators would implement the best maybe controls? You have seen what happened in France. This was a large data center, which means the company was rich enough maybe. They use container, they use fancy, I would say, decoration, which means they are not short of money. They had enough money, but somehow they didn't care much about the fire safety. I'm glad that no one was hurt in that incident. All people were safe in a good condition. But just imagine what would have happened if there was someone inside and these guys didn't implement the proper controls. This may hurt people. It will hurt it for sure. It costed them money. For sure, they lost a lot of money. For sure, a lot of websites were down. And because they didn't follow the regulations. So somehow there must be some authorities that put regulations, enforce it on building owners, data center operators, to make sure everyone follow the rules. In the US, we have for sure fire safety regulatory bodies. We call it NFPA in the US. Yeah, thank you, Ali. It is NFPA. Yeah, Daniel, I agree with you. It was something wrong in what happened in that OHV. So in the US, we have NFPA. And if you are the one who is responsible on planning the fire safety system or designing fire safety, for sure you must read all their regulations. If you are the one who is operating data center, if you are the one who is managing or controlling or have influence in data center design, you need to know NFPA. And even if you are a data center technician, you are the one to monitor this. Maybe it is good for you to know what is the name of the regulatory body, what are the regulations in your state. Maybe you have more regulations in your state than NFPA. So NFPA is federal-wise. Maybe in certain regions you have more regulations. So you need to know them and follow them. In Canada, we have the National Fire Code 2020. So different countries may have different regulatory bodies and different standards and regulations. Now, standards and regulations are similar, but standards are set by, I would say, professional entities like IEEE. Regulations are set and enforced by governments. So when it comes to fire, we have regulations because they are set, decided, enforced by government. So we call them regulations. Standards are the rules that are set by professional bodies. They are not enforced by government. We call them standards. I don't know what is Japanese one. Sorry for that, Stephen. But I'm sure they might have something. We focus on North America somehow in this course, Canada and US, but I would be interested to know what is in Japan, but I have no idea. Sorry for that. And NFPA also, they put some rules for evacuation. So typically there should be some drills and there should be evacuation plan. This evacuation plan should be communicated clearly to the employees. Oh, Logan, thank you. Maybe you are the one who should give this lesson to explain to us the NFPA, because I have never been into their trainings. Every year they ask us to attend safety courses every year, and they include something about the fire drill and fire evacuation, and you must know the assembly point in your building. You must know the plan to leave the building in case of fire. So these things are mandatory for every employee to watch every year, to know exactly the plan and not to be in panic mode in case of fire. And we must run the drill maybe 1 or twice per year. I don't know how many years, how many times we must run the drill to make sure. So everyone should know the role during the fire. In case of fire, there should be the plan should be communicated. There should be a way to communicate the plan and the direction during fire to everyone. There should be a plan in place. It should be communicated. It should be visible. It should be known by everyone in the building. Someone should inspect the fire suppression system, equipment. Maybe this will be you, maybe to do some visual inspection. Maybe you hire some professional contractors to do frequent check yearly, maybe quarterly check on the fire system. It is not only visual check. They do some sort of maybe triggering the system, see the response, make sure everything function as it should be. And there should be some way to conduct the drills, to practice, to know exactly what to do before there's any incident. Carbon detector, carbon dioxide, you mean? Yeah, typically there are different type of detectors to detect carbon dioxide detector. There are different detectors to detect not only the smoke but also to detect different gases in case of fire or case of. Now for carbon dioxide, okay, I have something to say. I skipped this, but when it comes to clean agents, in this lecture we discussed FM200 and Novec 1230. We discussed argonites or say energen. We discussed 1, 2, 3. We skipped carbon dioxide. Why? Do you know why we did not discuss it? Because oh, wait a minute. Yeah, we care about the humans. We don't want to suppress the fire and at the same time harm the people inside the building. So somehow we focused on the three of them. We focused on FM200, Novec 1230, Energen, and somehow we take this. Now, this lecture is not a full course. You will not be expert in fire system by only attending 3-hour lecture. There's a lot of information to learn, a lot to read. There are always new systems coming from time to time. So this one, it is not actually the environment, it is the human. So this course, this lecture focus on the main points here and there. But when it comes to carbon dioxide, thank you for the question, by the way. I skipped that, but I'm glad that you asked about it. So somehow we did not discuss carbon dioxide because it is not safe for human and not common nowadays. So we focused on what is common nowadays and what is used actually in data centers because there are many areas to cover and many subjects to cover. Now there's a video that I will not run. You can watch it. It is about NFPA. If you have no idea what is NFPA, you can watch this video. It is only 2 minutes video, I believe, or 3 minutes about NFPA, their role, what they do. And yeah, it is always good to watch it. Let me see, do we still have, yeah, this is the last video, you know. I'll just run part of it and then we'll conclude it for today. So we still have 6 minutes. I don't want to use up to last minute.
Hi everyone.
So let's see this video quickly.
Welcome back to our channel and a warm welcome if you are new to this channel. Hope all of you are fire and life safety resources. The organization is called the National Fire Protection Association or NFPA. The NFPA is a worldwide non-profit organization that was established in 1896 with the goal of lowering the impact of fire and other risks on people's quality of life by offering and promoting consensus rules and standards, as well as through conducting research, training, and education. With more than 200 people, it has its corporate office in Quincy, Massachusetts, in the USA. More than 300 codes and standards are created, published, and circulated by the NFPA, which offers recommendations and specifications for fire safety, electrical safety, and life safety. All across the world, including in the United States, these codes and standards are extensively utilized to ensure that the code.
Well, yeah, this is about NFPA, and in different countries, they may have different regulations. I'd like to finish 5 minutes before, so you have some time to ask and also to prepare for your next activity. Do you have any question about what we discussed today, or any comment, or any material you believe we should cover in this lesson, maybe? Now, last time we talked about A+. I will just give 2 slides about A+ training, which is something I hope you spend the time to read about it. So A+ course is somehow from CompTIA. So the exam A+ is actually 2 exams. The certification, they have 2 exams that you need to pass, 220-1201 and 220-1202. When you pass both of them, you'll be A+ certified, which mainly cover the basics of servers, computing, a little bit maybe networking, but not that much. And yeah, the thing is, once you pass both of them, you know about mobile devices, networking, hardware, virtualization, hardware and network troubleshooting. And also it includes some of the information about operating system, Linux, Windows, security, software. So they are the basics. They don't go deep. They discuss the basics. They don't cover for sure advanced networking. They don't cover fire systems, power systems, electrical systems. They don't cover everything in data center, but they focus on the IT system, on the components of the IT system, and they discuss the basic concepts in them, in each one of these areas. And this maybe help you to get hired for the first time, maybe. And it is a good start for your career if you want to know, if you want to become data center technician and to be promoted quickly. I would say certificates help, and A+ is one of them that you may need to consider.